cXDC's variable commands. Hi, I'm Becca Cole, Media Developer at ColeSoft Marketing. This series of videos is designed to help you learn more about cXDC, a new component feature of cXDC available with release Z2.2 that allows you to test your XLC, C++, and Metal C programs. Using information available from dwarf data, cXDC has full knowledge of almost all XLC, C++, and Metal C variable types, syntaxes, and formats. This video will discuss how you can use a variety of commands within cXDC to view, format, and modify those variables. Keep an eye out for the help headings listed on the left-hand side of the screen so you can reference topics in greater depth later on in the built-in help or the PDFs on our website. Also remember that you can pause this video at any time if I move through topics too quickly. Let's get started. Generally, variables in cXDC can be anything supported by XLC, C++, or Metal C. For example, simple scalar variables, arrays, selected array elements, structures, structure elements, structures within arrays within structures, etc., unions, and more. The different variable displaying commands in cXDC allow you to view these variables in different ways and to modify them as needed. The list variables command, abbreviated to lvar, allows you to display the current values for one or more variables belonging to any high-level language program that you have mapped. lvar with operands omitted shows all variables that are in scope or accessible within the current stack frame. You can use the L shortcut command, which we'll discuss more in a moment, to drill down into a parent variable. Alternately, you can modify the lvar command with operands to show different variables. Follow the lvar command with a variable reference to show the value of a specified variable. The variable reference can be any of the following: names that reference any kind of C variable, references to an entire structure or to individual members of a structure, or references to individual members of an array or selected ranges of array members, known as slices. Calling variables specifically can be used to directly list particular variables or arrays inside of structures or slices with no need to drill down from the parent variable or structure. The variable's value will be displayed, formatted according to the variable's type. We'll talk more about variable types in a few minutes. Any number of variables may be specified. A line of display will be produced for each variable. Variables can be in scope, accessible within the current stack frame, or out of scope. To display a specific in-scope variable, all you need is the name of the variable. But that won't work for out-of-scope variables. If you want to display a variable that is out of scope, you must use its stack frame to reference it. The syntax for specifying an out-of-scope variable is shown here. VS# is constant text. It stands for variable stack number. XX is replaced by the stack frame number. YY is replaced by GV, standing for global variable, SV for subroutine variable, or LV for local variable. Var is the case-sensitive name of the variable. In the specific case of LV, multiple levels of the LV pool exist. In that case, the stack frame name is as shown, where Z is the depth of nesting of the local pools. Area pound is constant text. As I mentioned a moment ago, lvar without operands only shows in-scope variables. It does not show variables that are out of scope. You can use the all operand to broaden the scope of the lvar display. If all is given as the sole operand to the lvar command, then all variables are listed from all stack frames, including variables that are out of scope. However, when all is given in combination with other variables, it is treated as being a variable name rather than an operand. In this case, there is no variable named all, so cXDC gives us an error message. An LEC or Metal C compliant subroutine generally has access to up to 3 variable pools. A local pool of variables declared only for the current block of code. A subroutine pool of variables declared for the current routine, subroutine, or function. And a global pool of constants. The default view for the lvar command shows one list for each of these variable pools. Local variables are shown in the first list. When execution is in a local block of code, the local variable stack is displayed at the top of the list. And if execution enters another local block, another local variable entry is added to the top of the list, moving the prior entry down. The second list shows the subroutine variables available only to the current function. These are variables that reside on the current stack frame, also known as the stack. Depending on how many variables you have, you may have to page down to view the third list. This final list shows the global variables, which are variables that are available to any function in your program. These variables are generally accessible from any function within the current compilation unit and reside on what is known as the heap. The lvar command produces 3 columns plus the standard shortcut entry fields at the left. The first column shows the variable's type as defined by dwarf. The second column shows the variable's name. The third column shows the variable's value. This third column includes cXDC's commentary if the variable's value is not available. cXDC may tell you one of several things about a given variable. Structure is hidden. cXDC knows the content but is not currently showing it. The L shortcut command can be used to reveal this content. Structure is not explored. cXDC hasn't yet examined the structure's content, but if you drill down using the L shortcut command, cXDC will discover the content and properly display the data. Unknown data. cXDC does not recognize the type of structure. Null pointer. The variable is a pointer variable, and cXDC has detected that at least one address pointed to is 0. In addition to these 4 common messages, cXDC may show one of these less typical messages. Invalid pointer. The variable is a pointer variable, and one of the address areas contains a reference to unallocated storage. Illogical location. The variable is a pointer variable, and one of the pointers references storage that cXDC knows is not resolvable. Location omitted from dwarf data. The dwarf data does not contain information about a variable's whereabouts, therefore cXDC is not able to find it. There are 8 valid shortcut commands for the list variables display. These commands may behave differently depending on where they are used within your program and within cXDC. Not all commands are valid for all types of variables. We'll discuss the different types of variables and which shortcut commands are applicable shortly. The lettered shortcut commands are commands already existing in cXDC that have been expanded to work within cXDC. L is the list shortcut command. In the list variables display, the L shortcut command drills down or expands and contracts a display. The behavior of this command depends on where the L shortcut command is issued. In the working window, entering an L in the shortcut entry field from the lvar display drills down to display only the expanded variable on screen. Using the L command to drill back up, however, behaves differently depending on what type of display was expanded. For structures, using L to climb out will automatically contract the variable display. For character strings, however, when climbing out, the character string remains expanded unless you specifically contract it first. In a watch window, the L shortcut will expand or contract a variable or structure in place, showing the new content within the previously displayed content. And when viewing arrays where a character string is too long to be displayed on a single line, L toggles back and forth between single-line and multi-line displays. D and F are the display and format shortcut commands. The D shortcut command is used to display storage using raw hex text or dump-like format. The F shortcut command displays the variable name in addition to the raw storage. In all other aspects, the F and D shortcut commands behave identically for variables. The value of the D and F displays is that they can be zapped, even for those variables where the Z shortcut command is not supported, but the user will have to know the hex equivalent of the data he wants to zap in. Z is the zap shortcut command. You can use Z to change the contents of a variable. Not all variables can be zapped. Currently, multi-byte character types such as wide, 2-byte EBCDIC or ASCII, and UTF-16 and 32 cannot be zapped. If you want to change the value of a variable, just enter a Z into the shortcut entry field for that variable, and then overtype the displayed value with a new value using the same syntax with which the variable data is displayed. Then press Enter. If you overtype a variable without also typing Z in the shortcut field, your changes will be ignored and no zap will occur. The last few shortcut commands are new commands specifically for cXDC. They manage how cXDC displays characters and character strings. cXDC supports 1-byte and 2-byte or wide ASCII and EBCDIC characters, as well as UTF-16 and 32. When the list variables command is used to display variables that contain character strings, cXDC attempts to show the text as ASCII or EBCDIC according to the program's default code set. However, this default can be overridden for individual variables, and unfortunately that override information is not available to cXDC, so it is possible for the text display to be garbled. cXDC has two shortcut commands to allow users to toggle variables between EBCDIC and ASCII. The vertical bar shortcut command forces cXDC to display the affected variable using the ASCII code set. The asterisk shortcut command forces cXDC to display the affected variable using the EBCDIC code set. Both the asterisk and vertical bar shortcut commands are valid for char and EBCDIC and ASCII UTF characters. The / and / shortcut commands determine how cXDC displays character strings. Character strings do not really exist as a high-level language data type. They are always built up of a vector of individual characters and have some sort of defined maximum length. The current working length of a string is defined by one of two mechanisms. Either the string has a length field associated with it, or the string contains within it a special reserved termination character, typically a null, which is a hex 00. The extent to which these facts are hidden from the high-level language programmer varies. In the case of C and C++, they are not hidden well at all. C programmers routinely deal with the duality of strings, sometimes treating them as a single object, yet retaining the ability and need to reference and manipulate the individual characters in the underlying array. Both string and array presentations have their uses. String format is more comfortable and does not waste screen space, while array format facilitates the use of the zap shortcut command when attempting to lengthen the content of the string. cXDC allows the user to choose the display format on a variable-by-variable basis. By default, cXDC displays strings using their null-terminated logical length. The / or array shortcut command causes cXDC to display the affected variable using array size paradigm. This option causes the entire defined area to be displayed and does not react to the null string terminator. The / or string shortcut command causes cXDC to display the affected variable using the null terminated paradigm. Two different commands control how the list variable's output is displayed on the screen. The setVDisplay command controls the output display formatting, such as column width. The setVSettings command controls the number of array dimensions displayed and the depth to which stack frames can be listed by the lvar display. The set vSettings command also accepts two additional keywords. Set vSettings reset looks for and displays changed variables. cXDC typically issues reset internally, so it is not often needed by the user. Set vSettings rebuild discards and rebuilds variable pools. cXDC displays several different types of variables, formatted and displayed in different ways. For some, but not all, of these variable types, you can change the way the variables are displayed using shortcut commands. cXDC understands and formats binary, hexadecimal, and decimal floating point numbers. cXDC formats the hexadecimal strings of floating point numbers into human-readable decimal mantisas. Floating point numbers will only accept the D display, F format, and Z zap commands. The format of the display for floating point numbers cannot be changed using the other variable shortcut commands. cXDC displays integer values as whole numbers. Integers will only accept the D, F, and Z commands. Normally, cXDC will display text interpreted as ASCII or EBCDIC according to the C program's compiled default. When a string is being incorrectly displayed, you can coerce the correct display by using the asterisk and vertical bar shortcut commands to override the program's default. ASCII and EBCDIC displays will accept all of the variable shortcut commands. By default, cXDC displays only the first line of long text strings. Use L to expand long text strings and index the characters. Long text string displays will accept all of the variable shortcut commands. All strings in C are null terminated, meaning that the last character is 00. However, it is possible to have multiple strings stuck in a buffer somewhere. cXDC shows only the first string by default. The / command allows you to see the full contents of the array. Broken text string displays will accept all of the variable shortcut commands. A structure is a way to organize related fields and variables together. Unions are a special form of structure where the variables defined within all overlay each other, allowing a variable to be treated as more than one type at a time, such as both character and float. Structures may be embedded within other structures or arrays. cXDC can display structures and layers of structures within structures. As I mentioned earlier, in the working window, the L shortcut command will cause cXDC to step in and show you the substructure. In secondary windows, L will expand or contract the substructures in place. Structure displays will only accept the D, F, and L commands. In the case of pointers, cXDC will display the actual variable that a pointer points to, rather than the address a pointer contains. The shortcut commands available for a pointer variable will depend on the type of variable pointed to. For instance, an integer would only accept D, F, or Z. cXDC remembers formatting settings per variable. If, for example, you expand one variable and then reissue list_var, that variable will be expanded on the refreshed display, but others that have not been expanded will still be displayed truncated. The same is true for the other formatting shortcut commands, such as for ASCII and EBCDIC or expanded structures, etc. cXDC will indicate the current formatting option for any manually changed settings in the LVAR display. We talked earlier about the three variable pools accessible to a subroutine: the local pool, the subroutine pool, and the global pool. As one subroutine calls another, new subroutine pools and local pools are created. Variable pools are created in structures known as stack frames. As subroutines are called, variables declared in the calling routine are generally unavailable to the called routine. cXDC has a mechanism to allow the programmer to access those variables in older stack frames, the list VSTACK command. List VSTACK, which stands for List Variable Stack and can be abbreviated to LVSTACK, is the default command for cXDC's watch window display under the C80 or C-wide profiles. For each of the variable pools we discussed, VSTACK generates a stack frame conveying the following information: the sequence number of the stack frame, the type of variable pool, global, subroutine, or local, and the location of the variable pool. VSTACK uses stack frames to show where you are in your program and how you got there. Every time a function calls another function, a new stack frame is created. As you step through your program and step into functions, the stack will grow as stack frames are added and updated in real time following your execution progression. The stack frames are displayed from oldest to newest. The topmost item that is displayed is the oldest stack frame, typically that of the main function. For each stack frame, the resume address is displayed for the routine that owns the frame, and information is displayed about each variable pool that is owned by that frame. In older stack frames, VSTACK shows the address of the next machine instruction immediately following the instruction that created the newer stack frame. The location shown in the previous stack frame indicates the location where the current function was called. If a stack frame was created by calling a subroutine, older stack frames will display the address that the subroutine returns to. The running list of stack frames also provides quick access to the local variable pool for the current execution location, as well as to prior stack levels. The F and D shortcut commands can be used to display the resume address location or variable pool storage. Entering the L shortcut command for a particular stack will bring up a display in the working window of the specific variables within that variable pool. Now you have an introduction to cXDC's variable commands. You can always find more details in our help documentation. Our next video will talk about mapping in cXDC. If you have any comments or questions about this video or about anything else having to do with cXDC or cXDC, feel free to contact our staff directly. We can be reached at techsupport@ColeSoft.com or by phone at 540-456-6164. You can also find more information on our website, www.ColeSoft.com, and in our LinkedIn users group, www.xdc.com. Thanks for watching.